All right, just as a quick warm-up, I'd like to review finding outside information to be able to solve a problem. So when you read this, there's actually quite a few things that need to happen first. So we're writing an equation through these 2 points. The first thing that I want to do is find the slope. All right. So y1 minus y2 minus y1 over x1 minus x2 using parentheses. So my slope is 2. All right. Now I have 2 points. I can pick either one. It actually doesn't really matter which one. And I'm going to use it in the equation, the point slope form. Now you can use either equation. That's just fine. You're going to end up at the same answer. So y minus y1 equals the slope times x minus x1. When you subtract a negative, it's like adding. All right. So all of this extra work is just to try to get it to our answer. All right. So now we need to get it in slope-intercept form. So I'm going to distribute my my slope in. And then add 5 to both sides. So you end up getting y equals 2x plus 9. And the cool part about this is, let's say I used my other point, y subtract y1 equals the slope x subtract x1. Let's see what happens if I distribute the slope in. Am I going to end up with the same answer? And you do. Okay. Add 7, and look, we end up at y equals 2x plus 9. So they are the same line. You're just deciding to use one point versus another. Okay. Again, the end in slope-intercept form, so make sure that you're looking for what the end question is. 2.5 is looking at scatter plots. And scatter plots, the idea is pretty straightforward, but the key with the scatter plot is just to look at a bunch of examples. So there's 2 parts to the practice today, and the reason for that is I can tell you the answers, but I need you to be able to see them. So you need to just practice with lots of scatter plots to get there. Okay, so we're looking at, what is a scatter plot? So a scatter plot is between any 2 variables, and it makes the most sense when the variables have like a relationship. For example, the weather outside being warm and the amount of runners on the trails, one would increase as the other increases, right? They have some sort of correlation, but not all scatter plots have a correlation. So when you look at this one, okay, we've got our 2 points. We can even draw in what's called a trend line. Trend line shows what the data kind of follows, the pattern or form that the data follows, and it's actually called the line of regression when it is a linear trend line. Okay. Correlation talks about the relationship between the 2 points. All right. The key words that we use, let's say if it was like 4-question multiple choice, right? We would be looking at these 4 words. All right. No correlation is when it's completely like you can't tell if it's positive or negative or what's going on. All right. Positive is when the graph looks like the pattern is moving upwards. Like if you were to draw a linear trend line in, it would be a positive slope. Okay. You could have it weak or strong. Strong, right, is just when it's close to the line. All right, so close to the line. Closer to the line is stronger. You can also have negative trend line, negative correlations. Negative, these are negative examples, and that would be when you were looking at the grouping or the form or the line, it would be a negative slope, all right? The closer it is to the line that you draw in, right, makes it stronger. So this one is also strong because they're close to the line. Okay? close to the line. So kind of identifying it, if you look at this, one thing that I like to think about is that, actually we need to make this, there you go, is what would happen if I drew in a trend line. Okay, so here's my trend line. The dots are close to the line, so that means that it's strong. The direction is moving down, so it's a negative, so it's a strong negative. Correlation would be the words that we use. What does it tell us? It says that as time increases, the percent remaining decreases. Well, that actually makes sense because it's talking about battery life. So I drew in the trend line for you, okay? And so you need to kind of look and say, well, how close to the line are all of my dots? Not very close, right? Not very close, and I'll draw it in. So, not close to line equals weak, right? The trend line is going up, so it is positive, but weak. It's very weak. You can almost say no correlation, but since the trend line was drawn in, there it is. So this is between homework percent and your MCA practice score, and it looks like there is a weak to no correlation. That means that your achievement on homework is not necessarily an indicator of how you'll achieve on the MCAs. This one is another just kind of one I found on the internet. I was talking about brightness in the candle and degrees of error. So you can see this is a strong, the dots are so close to the line and it's negative. When it's strong, that tells us there's more of a correlation between the two variables, and the brightness goes down as the degree of error increases. So to get some extra practice with this on your own, please do the Desmos activity first. I think the link should work. I tried it out, and I made different codes for each class. The graded assignment is the quizzes. All right, happy solving.